Great. So at this point, I think that we still have a few minutes left for a broader discussion period with all of our speakers. So if people have questions or topics for discussion for all of our speakers, please feel free to come up to the mic or the chat session. One thing I thought we might start with is the topic that we started talking about at the end of Andrew's presentation about their volatile migration model that he didn't really present here, but he started talking about it a little bit. I wonder if you want to talk about that a little bit more and how it might relate maybe to some of the other presentations.
Sure. Yeah, our volatile transport model is it's not exactly a ballistic model, but it's similar. It's basically imagine we can take one of those surfaces we initialized and just cover it with some initial, like layers of mono layers of H2O, for example, and let this model run through time and see where those molecules end up going via analogy with, we can basically model that transport as a radiative process because the length scales are small enough that you don't have to do it ballistically. Yeah, what we're basically seeing is that even with these kind of small apertures that might affect the escape rates of these particular volatiles, they still escape quite efficiently. And so right now we're trying to nail down kind of the supply rates that you would need to maintain volatiles within these environments. So how much would you need coming in through these cave openings to maintain volatiles here?
Then does the size of the cave opening matter? Did you say that already?
Yeah, so I think it matters less for the temperature situation, but it could matter for the volatile situation, and that's exactly what we're exploring right now. I think that's going to end up in the paper.
And then I had a follow-up too, because when you gave your presentation, I didn't see what you did to your modeled crater or pit within a crater to make it doubly shadowed. How did you do that?
So basically it's just a function of geometry. So that whole feature is at 80 degrees south latitude. And so if you put a crater of that, depth to diameter ratio at that latitude, it's going to have a PSR in it. And then I can just put the pit at the bottom of that crater. And so that pit is within that PSR that will exist in such a crater.
But initially it wasn't double-sided or double shadowed.
Yeah, so before adding that crater, it's just assuming that the pit opening is just on a flat ground outside of some larger feature. Yeah. I see. Okay. So we're not assuming anything about the topography beyond that. Yeah.
Okay, thank you. Who else has questions or topics?
Can I ask a question? I have a question for Ariel. Can you estimate how much ice you will need to make a degree of a slope difference between the pole facing and the equatorial facing?
Yes, I don't have the answer to it yet, but that's actually something Leo and I were talking about just this morning. Essentially modeling the geometry that you would expect without the infill, and then looking at the slope change, what that means both for if it was just infill or also if you assume some sort of movement process too. So TBD, but yes, that is something we're hoping to constrain.
Okay, any other questions or topics from online or Norbert?
None in the chat.
Okay. Oh, go ahead.
Question for Ariel. have you looked at any latitude dependence with this slope effect?
No, not specifically. We've only looked at craters between 80 and 90 south, and I haven't looked at them in any sort of latitudinal rings of that data set. So no.
Cool, thanks.
Thanks.
Well, I think that will conclude our discussion period then. And I think we're just about to our break time anyway, but then after that, we've got Volatiles and PSRs II with a new set of chairs. And so don't forget to come back for that one. And let's have a final round of applause for all of our speakers.